What if I told you that the huge, complicated process of aging might just come down to a tiny little switch inside ourselves? Well, today we're going to explore that idea. We're diving deep into the world of our cellular power plants. Yep, the mitochondria, to really get a handle on their connection to how and why we get older. Just think about that quote for a second. It's from a physicist, John G. Kramer. And that's not just some wild guess. It's a serious calculation from a scientist who is so confident he's literally betting his own life on it. This is where our story starts. A story about science, about incredible courage, and about what it means to push the absolute limits of human life. And this story, it gets really personal. It begins with the physicist himself, who decided to turn his own body into one last, incredible experiment. Yeah, you heard that right. At 90 years old, Kramer is not sitting on the sidelines. He's an active volunteer in a cutting-edge clinical trial, getting infusions of mitochondria grown in a lab. He has effectively become his own final experiment, a living, breathing hypothesis for a new theory of aging. Okay, so that just begs the question, what in the world are these mitochondria that he's putting so much faith in? To really understand the gamble he's taking, we've got to understand these little engines of life. You probably remember hearing about these in high school biology. They're called the power plants, or the powerhouses of the cell, and for good reason. These tiny organelles are the engines that crank out nearly all of the chemical energy our cells need to do, well, everything. But here's the thing, they do way more than just make energy. They're also the cell's command and control center. They're the ones who give the order for damaged cells to self-destruct, which is a good thing. They keep calcium levels in check so our muscles and nerves can fire correctly, and, critically, they're in charge of our immune system and inflammation. They are running the whole show. So if they're that important, what happens when these power plants start to fail? Well, that question gets us right to the heart of the aging process itself. Now, this isn't some brand new, flashy idea. Scientists have been connecting these dots for over 70 years. But the theory really got its moment in the sun in 2013, when a landmark paper called it one of the core hallmarks of aging. And even a decade later, as our understanding has grown, the decline of our mitochondria remains an absolute cornerstone of the science. And it's not like a switch just flips off one day. It's a cascade, a domino effect. First, they start to get leaky and inefficient. Then their actual power output drops. And because our body's cleanup crews get slower as we age, these broken down power plants start to pile up like junk. To top it all off, their own DNA starts to mutate, which just creates a vicious cycle of more and more damage. And this breakdown inside our cells isn't just some abstract science concept. It's the common thread that runs through so many of the diseases we associate with getting older. We're talking Alzheimer's, Parkinson's, heart failure, diabetes, you name it. The pattern is always there. When the energy supply starts to sputter, the whole system starts to fail. And this all leads us to a really big shift in perspective, a totally new way of thinking about what aging actually is on a fundamental level. To get it, let's look at a puzzle from a totally different area. Cancer therapy. So why is it that a super advanced, perfectly targeted immunotherapy drug will sometimes just flop? The science is perfect, the drug is perfect, but nothing happens. What's going on there? Well, the answer turns out to be pretty stunning. It's not that the drug is failing, it's an energy failure. The body's own immune cells, the T cells, are often just too tired. Their mitochondria are too worn out to actually carry out the attack order the drug is giving them. It really all comes down to this. A healthy T cell, one with strong, fit mitochondria, is a warrior. It's effective. But an exhausted T cell, which is really common in older people, just doesn't have any gas in the tank. It can't keep up the fight. It's like sending a soldier into battle without any ammunition. So this just reframes everything. Aging isn't just about wrinkles. It's a crisis of energy and a crisis of immunity. See, if our body's own defenders don't have the power to fight, then the whole system is left vulnerable. So fixing our mitochondria isn't just about feeling more energetic. It's about rebooting our body's most essential defenses. So unless you're planning on getting lab-grown mitochondria like John Kramer, what can the rest of us actually do? Well, the good news is there are some really powerful things you can do in your daily life to recharge that cellular grid. And you can start today. A lot of the time, getting healthier is about subtraction. It's about what you stop doing. And this list here probably won't be a huge shock. We're talking chronic stress, not moving enough, eating a lot of processed junk, not sleeping well. All of these things are like pouring poison on your cellular engines. They just speed up the damage.
All right, now for the good stuff. The habits that actually build them back up. Things like high-intensity exercise literally send a signal to your body to build brand new, better mitochondria. Deep sleep is when the repair crews come out. Fasting helps clear out the old, broken ones. These aren't just vague healthy tips. They are direct, science-backed ways to overhaul your energy grid.
When you boil it all down, the science is pointing us to a powerful new idea. Aging, at its very core, is an energy problem. And, understanding that, it gives us a real sense of control. It puts some of the power back in our hands. So the question I'll leave you with is a personal one. If aging is an energy problem, how are you going to recharge?